Writing equations from real-world situations. We're going to start with number 1. I like to read through the information first and then read it a second time to underline information. So looking here, due to a drought, the canal from a reservoir is open so that the reservoir is lowered. So I think that's a key point here, to meet the irrigation needs for farmers. The level of the water is being lowered from 160 feet. So from 160 feet helps me think of that's probably where the water is starting, by 15 feet per day. 15 feet per day. Anytime I see that word per, that's a division, and that helps me know that I am talking about a rate until it hits its lowest point at 85 feet after 5 days. So another piece of key information there. When I look at your work, I should see it marked up like mine, where you have key information highlighted or underlined or circled. And so for here, we know after 5 days, and we have a table here that's set up where x equals days and the water level in feet is our second variable. So this is our x, this is our y, and we know that after 5 days, that's what this is right here, we have 85 feet of water. So we can fill that in our table. We also know this 160 feet. So the water is being lowered from 160 feet. That seems to be our starting point here, that we started with 160 feet of water, and now we're losing 15 feet because it's lowering, it's going down, which means it's going to be a negative value. Since we know the water is being lowered by 15 feet, we know that we can take 160 and subtract 15 from that. That's going to give us 145 feet, and we can subtract 15 again. That's going to give us 130, and keep subtracting 15 until hopefully we get 85 right there. So I've labeled my days and my water level here. We're just doing a quick sketch. We're not going to use the graph to predict our values because we won't be able to graph this as accurately as we would need to predict values, but we can get an idea of what type of graph this is. So I'm going to just go one box for each day. And in order to go on my water level, if I go by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 120 isn't going to quite measure for this. And because our rate here is 15, I decided to go by 15s. So 15 feet, 30 feet, and so on up my graph. You don't have to plot, you don't have to label every single line. So I want each box to be 15, which means every 2 boxes is 30. So instead of going 15, 30, 45, 60, and then keep going, I just decided I'm going to label every 2 as 30 just to make a nice even scale here. And now let's plot some of those points. So we're told that our irrigation starts at day 0, or at the start at 160. So this is 150, this is 180. And we could also look at day 5 that I should be at 85 feet. And if we look between here, this would be 75. So if we divide these two into sort of thirds, this would be 70, 80, 90. So 85 would be kind of up in here at day 5. You can plot more points, but you don't need to. They're going to all fall in the line, and we can kind of check that. So I'm going to connect my points and take a look at what this is going to look like. Now, if I want to look at 1, it's going to be at 145, which is a little bit lower than 150. That looks reasonable. At 2, I should be at 130, which that's a little bit above 120. That looks reasonable. At day 3, I'm at 115, which is a little below 120. That looks reasonable. So you can see that a straight line seems to be fitting this model. And we also see that in our table we had a change in y of -15 and the change in x is +1. So we do have a constant rate of change. Also indicated in our word problem, the words up here at -15 feet per day, that's our rate. Change in y over the change in x. So what type of function is this? How do we know? We say that this would be a linear function because we graphed it and got a line. And we also, another way you could say that is because it has a constant rate or rate of change or slope. What is the general form of a linear equation? Remember, we have two general forms. We have slope-intercept form and we have point-slope form. In a case where we know easily the slope-intercept, which we do, or I'm sorry, the y-intercept, then it's most common to use the slope-intercept form. So make sure you write down y equals mx plus b for the equation that we're going to use. So what is the starting point or y-intercept? If we look back at our graph, our y-intercept is right here at 0, 160. So our y-intercept 0, 160, or you can think of that as 160 feet for the context of this problem. What is the rate of change? Look above to see the rate. You can see that in two places. You can see it in the words that we are lowered by 15 feet per day, or you can see it in our table of -15 or subtract 15 feet for each day. To write an equation that represents this situation, we know that we get y values. We can substitute it right here by knowing that our rate of change is the m and that the y-intercept is our b value. We can also just think in the context of this problem. We start with 160 feet of water and we're subtracting 15 feet per day. And each day is represented by x. So we could think of this as 160 minus 15x. It could also be written more traditionally in slope-intercept form, but I think it makes more sense in the context of we started with 160 feet of water and we are subtracting off 15 feet for each and every day. That's what we did in our table. We started with 160 and we're subtracting off 15 for each of those days. So if this community continued to drain water out of the reservoir, if the drought continued, and we wanted to know what would the water level be after 10 days, how could we find that out? We could do a couple of things. We could continue the table. Or we could use the equation. So we could just continue up at our table and say, okay, it's not that many more. I'm going to subtract 15 for each of those values. So if we do 85 minus 15 and hit enter, we get that there would be 70 feet next. If you just hit enter again, we have to do subtract. If you hit subtract 15, and that's the answer minus 15, and hit enter, we now get 55. And now if you hit enter again, it's going to keep taking the answer and subtracting 15. So we would get 40 after 8 days, and it would be 25 feet after 9 days, and it would be 10 feet after 10 days. Let's verify that using our equation. So keep in mind in our equation that y is the water level and x is the number of days. So after 10 days, if you're losing 15 feet of water per day, that's 150 feet of water that you're losing. So it would be 160 minus 150, and then that would be 10. So we would still get y is equal to 10 feet after 10 days.